Here, the question has given a clock. The minute hand of the clock hanging on the vertical wall has a length L. The length is 30 centimeters. The minute hand is observed pointing at 10, and then again 30 minutes later when the hand is pointing at 6. So, originally, the minute hand was at this particular position when it is pointing towards the 12 marker. 30 minutes later, this minute hand will be pointing towards the 6 mark. So let me draw the final position of this minute hand will be in this particular direction. The question is, what is the average velocity and average speed? So let's start with average velocity. Average velocity is displacement upon time. So what is the displacement of this minute hand? Before we do that, we need to understand how the minute hand is actually moving. So this is a clock. So minute hand, the tip of the minute hand. So consider this point P. This point P is going to go in a circular arc. Let me draw a dotted line. So it is going to move in a circular arc. Average velocity was displacement divided by the time. What will be the displacement of the point P? So initially the point P is over here. And finally, after 30 minutes, the point P reaches over here. So what is displacement? It is the straight line which connects the start point to the final point, which means we need the length of this line segment. And incidentally, the entire length is actually the diameter of the circular path. And diameter, if we recall, is double the radius. Radius of the circular path is L, which was 30 centimeters. So if we double it, that will give us the diameter. So diameter will be 60 centimeters. So for velocity, we will write displacement in the numerator. So it will be 60 centimeters in the numerator. And the denominator is, of course, the time. Time is 30 minutes, as they have mentioned in the question. So let's write in the denominator 30 minutes. And if we simplify this, we will get 2 centimeters per minute. This is the magnitude of the average velocity, which means now if we look at the options, the answer is either A or B. For the direction, all we need to figure out is where is the particle with respect to the start point. So here the particle point P was over here and finally it went down. So the end point is below the start point. So we will say the direction is actually downwards. So average velocity is 2 centimeters per minute but vertically downwards. Hence, of course, option A will be the answer. Let us also find out the magnitude of average speed. Average speed, remember, is distance upon time. So what will be the distance traveled by the particle P? As the particle P is moving in a circular arc, so in a span of 30 minutes, it is going to cover the entire length of this dotted line. And incidentally, this is half the circumference. Now, if you remember the formula for circumference of a circle, that is 2 pi r. And for this situation, distance traveled by the particle point P will be half the circumference. So the distance traveled will be pi r, and we will divide that by the time taken. This will give us the value of average speed. So pi multiplied by r, radius of the circular arc is 30 centimeters. So let's write down 30 centimeters, and time taken, of course, is 30 minutes. So if we simplify this, we are going to get pi centimeters per minute, which means average speed is pi centimeters per minute, and hence option A is the right answer. So here we have a car which is moving clockwise in a circular path. The direction of the instantaneous velocities are two times are given, v1 and v2. Which of the following vectors shows the direction of the change in velocity? Pause the video, attempt it on your own, and then look at the solution. Since we have to find the change in velocity, what exactly is meant by change in velocity? It is just the difference between the two velocities. It is final velocity minus the initial velocity. Here, the final velocity is v2, initial velocity is v1. That is why we have written here delta v, which is the change in velocity, that is v2 minus v1. Now, remember the trick. How do we subtract? We will transform this equation into this form where we have written v2 plus negative v1. Let us proceed. Here v2 is downwards and v1 is rightwards. So using the two vectors, let us connect and create a diagram. And here we have to figure out negative v1. And remember, negative v1 will just reverse the direction without changing the magnitude. So if v1 is to the right hand side, negative v1 will act towards the left hand side. And now we will use the law of vector addition using the two vectors v2 and negative v1. Step 1 is to create the parallelogram, which in this case is the rectangle. Step 2 is to draw the diagonal. And this diagonal will give us v2 minus v1, which is the change in velocity. And now if you look at all the options, it is option C which matches with this direction, and hence answer is C. A car moves south at 20 meters per second and changes direction by moving north at 30 meters per second. Which vector best represents the change in velocity? Now, I will just start with the most common mistake which a lot of students do since they see 20 meters per second and 30 meters per second, and then they just subtract them because change in velocity is nothing but subtraction. So once we do 30 minus 20, that will give us 10, which means the answer would be either A or B. But that approach is actually wrong. The flaw in that approach is we are considering velocities and not speeds here. Velocity is a vector quantity, which means it is not only having the magnitude, but also the direction. We are supposed to take care of the direction. Let me explain how do we do that. So the car is moving south at 20 meters per second. So over here, I have drawn a bottom going arrow, which is V1, whose magnitude is 20 meters per second. And then it is mentioned in the question that the car changes direction by moving north at 30 meters per second. So the car starts at this point, and when it reaches this point, this is where the direction is changed, and we can draw another arrow but going upward. So that will be V2, whose magnitude is 30. The question wants us to find the change in velocity. Change in velocity, remember, is final minus initial velocity. In this case, that will be V2 minus V1. V2 is having a magnitude of 30 and it is going in the upward direction. So we are going to assume upward direction as positive. So V2 will be positive 30. But V1, as you can see, is going downwards. So the magnitude is 20. But since it is going downwards, we are going to consider negative 20. So the change in the velocity will be 30 minus negative 20. That is the key factor. And if you solve this, we are going to get 50 as the answer, which means A and B are actually wrong. The answer is between either C or D. And how do we figure out which answer is correct? We go back to the concept of change in velocity, which is V2 minus V1. Now remember, how do we subtract the two vectors? So we will transform this equation in this form. So V2 plus negative of V1. Hence, V2 is fine. We will keep that as it is, but V1 needs to be reversed. So if I draw another diagram where V2 is drawn as it is, but we will draw negative V1. V1 is going downwards, so negative V1 will go upwards like this. Magnitude remaining the same. Here we are having two vectors, V2 and negative V1. And as you can observe in this diagram, these two arrows, both of them are pointing upwards in the same direction. And we know whenever two vectors are pointing in the same direction, the resultant is found by addition. So we will add 30 and 20 to get a 50. And the direction is represented by this arrow. And that is why the answer for this question is not C, it is option D. Now, the next important parameter after distance, displacement, speed, and velocity is acceleration. So, acceleration is the rate of change of velocity, and the formula is acceleration is the change in velocity divided by the time taken for the change. This formula is extremely important for exam questions. So, just remember A is delta V upon delta T, where delta V stands for the change in velocity. But please do remember velocity is a vector quantity. So if we are finding the change in velocity, we have to consider magnitude as well as direction. And don't worry, we are going to solve a question specifying that aspect. Now, what will be the unit of acceleration? Since acceleration is the change in velocity upon time, numerator is velocity, which is meters per second, and time in the denominator is seconds. So if you simplify, the unit of acceleration is meters per second square. Now, since velocity is a vector quantity, that means acceleration will also be a vector quantity. Acceleration can happen in three ways. So please understand this one by one. Step number one, if the speed of the particle changes, that means it can either accelerate or decelerate. So imagine a situation where the particle is moving in a straight line, but either the speed is increasing or decreasing. That means the object is accelerating. If the speed increases, we say it is accelerating. If the speed decreases, then we say it is decelerating. So this was point number one in which acceleration can happen. Point number two is if the direction is changing. So imagine a situation where the car is moving with a constant speed, but it is continuously changing its direction. So even though the speed of the car is constant, that doesn't mean acceleration will be zero. Acceleration is non-zero because the direction is changing. And that is why I said for acceleration, we need to take care of magnitude as well as direction. So imagine a particle moving in a circular path but with a constant speed. That means acceleration is not zero because the direction of the movement of the car is continuously changing. So these were the 2 points. Point number one, if the speed is changing but direction is not changing. Point number two, if the direction is changing but the speed is constant. Point number three is if both these parameters are changing. So imagine a situation where the speed is changing as well as the direction. That also means acceleration is happening. Let's take a few examples. So look at this diagram. We have a car which is moving at a constant speed in a straight line. So the direction of velocity is towards the right hand side. In this case, since the direction is fixed and the speed is also fixed, as it is constant speed, so acceleration will be equal to zero. Example number two, imagine a situation when the car is speeding up, which means it is accelerating. So the direction of velocity is to the right hand side and direction of acceleration will also be to the right hand side. That is why the car will speed up. On the other hand, if the car is slowing down, which means imagine a car is moving forwards, in this case, the car is moving towards the right hand side. For the car to slow down, the direction of acceleration should be opposite to the velocity. So, for the exam questions, just remember this as a rule. If the direction of velocity and acceleration are the same, then the car will speed up. But if the velocity and acceleration direction are opposite, then the car will slow down.